Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving construct smallest number from di string. And di just means decreasing, increasing string. D stands for decreasing and I stands for increasing. So the problem states that you are given a zero index string pattern of length n consisting of characters I meaning increasing and d meaning decreasing. So this zero index string num of length n plus 1 is created using the following condition. The string will consist of digits 1 to 9 and each digit can only be used at most one time. So if the pattern is I, then that means it is increasing in the next element. And if it is d, then it wants to be decreasing in the next element. And finally, we want to return the lexicographically smallest possible string num that meets all the conditions above. So if we look at this example, the first 4 numbers are in an increasing state because the first 3 letters are increasing. So 1, 2, 3, 5. And now it wants it to be decreasing. So we decreased it to 4 and want to increase it again, increase it to 9 and then 8, 7, 6. So it's pretty easy to see the smallest possible string if we can just manually do it, but it's not as easy to figure it out in code. But now that we have seen some examples, let's see how we can solve this problem. So the most simple way that we can solve it is we loop through all the string possibilities from the smallest to largest. So we'll start from 1, 2, 3, 4, 5, 6, 7, 8, 9 to 9, 8, 7, 6, 5, 4, 3, 2, 1. And as we are looping through all these possibilities, we want to check if that string satisfy the input condition, and if it's yes, then we return the string because the first string that satisfies the condition will be the smallest one since we are checking from smallest to largest. And the time complexity of this approach would be n times n factorial. Well, technically n plus 1 factorial, but in time complexity we can avoid the constants, so n times n factorial, and that's because there are n factorial possibilities of strings, and it also takes n time to check if the strings are valid. So there's actually a much more efficient way to solve it, and we can go over that way right now. One thing I like about this approach is that it's pretty hard to come up with, but it's pretty easy to understand compared to some of the problems that are out there. So basically how we can solve it this way is to use a stack and a resulting string, and it will be initialized as an empty string. So as we loop through this input string called pattern, whether it's I or D, we want to add the number to the stack, incrementing by 1 each time and starting at 1, of course. So here we'll add 1 to stack, add 2 to stack, 3 to stack, 4 to stack, 5 to stack, 6 to stack, 7 to stack, and 8 to stack. And also we will add 9 to stack because we want to add 1 extra number than the length of the input string. So if you look at all the outputs of the inputs, it's always 1 number more than the input that we are given. However, the difference between I and D is that when we come across an I, we will add the number to the stack and immediately pop everything from the stack and add them to the resulting string. And if we come across a D, then we just add it to a stack and don't touch the resulting string just yet. And when we get to the end of the pattern input string, we will add 1 more number and we will have to add everything left from the stack to the resulting string. So I think the algorithm I just explained will make a lot of sense as I go over this example. So let's go over this example right now. So first we come across the first I, so we will add 1 to the stack and immediately add it to the resulting string. As we add to the resulting string, we pop that element from the stack. So we pop it. Now at the second I, we add it to the stack and we also add to the resulting string and pop it here. At the third I, we add it again to the stack, add it to the resulting string, and then we pop it here. Now we come to the D. So D, we just add to the stack and don't touch it just yet. Now we come across I again. So we add it to the stack. And now, since it's an I, we pop everything from the stack and add it to result. So add 5, pop 5, add 4, and pop 4. So now we come across D, and the number is 6. Add 6, don't do anything. Come across the next D, add 7, don't do anything. Come across the next D, add 8, don't do anything. So now that we have come to the end of the string, we will need to add 1 more number, and 8 plus 1 would be 9. And again, since we are at the end of the string, we need to pop everything that we see from the stack. So pop 9, add 9, pop 8, add 8, pop 7, add 7, pop 6, and add 6. And this would be our resulting string that we return. So the time complexity of this approach would be O of n, where n is the length of the pattern input string, because the time would depend on the length of pattern linearly. And the space would be O of n also, because of the stack that we create, it can take up to n space. So now let's get to the coding part. So first we'll have a starting result and the starting stack. So now we want to loop through the indexes of the pattern, length of pattern plus 1, and at every iteration we want to add I plus 1 to the stack. And if I is equal length of pattern, meaning we are at the end of the string, the end of input string, or if the letter or the character is I, then we want to add everything to the stack and pop everything from the stack. So result.append the string of stack.pop, and at the end we can just return the resulting list as a string. Alright, let's see if it works. Okay, perfect. Thank you all for watching. I hope this was helpful. If you have any questions or comments, feel free to leave it down in the comment section, and I hope to see you all again soon.